All right, for lesson 3, we're going to focus on our rational expressions and simply multiplying or dividing. Of our next 3 lessons, this will probably be the easiest one. It's going to be maybe a little bit easier than last time. I know that doing the graphing is a little more challenging than we would like it to be, and so good job so far. But one of the fun, I think it's fun, things that we got to do in the last lesson, the last couple lessons, and really for the last couple months has been factoring our expressions. We're going to continue doing that. We need to be able to factor today if we are going to be successful with our work for the next several class meetings. So today kind of lays that groundwork, relays that idea of how do we factor well. But when we're multiplying and dividing these rational expressions, we're going to want to do some simplifying along the way. So again, rational expressions are basically the algebra version of fractions. And so we're working with fractions that involve x's and other, x's squared and quadratics and cubics and quartics and having to do all that factoring along the way. When we are multiplying and dividing with these fractional expressions, we want to make sure that we know how this works with arithmetic. If we understand it on the arithmetic side, it makes it possible for us to do the same thing with algebra. Again, the whole purpose of algebra is it doesn't really matter what the numbers are. And so if we have a good firm foundation of the arithmetic and we understand the arithmetic process, then the algebraic process is going to work itself out. But if we struggle with understanding this, which I know that we do, welcome to America, we try to struggle with working with fractions, we're going to try our best to handle this well. And so the way that we simplify fractions isn't just type it in our calculator and simplify, because your calculator's not going to do it when there's algebra involved. So we want to make sure that we understand this process of how fractions are simplified. And so what we have here is I've got 48 written as 3 times 16, 15 written as 3 times 5. In your elementary class, they would say, oh, just cancel those out and you're left with 16 over 5. And that's not wrong. But I want to get into the nuts and bolts of why these things cancel. And so really what's happening when we have 48 fifteenths is we have that 3 times 16 and that 3 times 5. And we understand that this is broken down as 3 over 3 times 16 over 5. And we know that 3 over 3 is the same thing as 1 times now 16 over 5, and we know that anything times 1 is just equal to that thing. And so what happens when you're learning about this process of simplifying fractions in elementary school is they say, instead of taking this and writing it like this and then doing that to just get this, what if we canceled those out? Right? It's a factor of 1. When we have a factor of the same number in numerator and denominator, that becomes a factor that's equal to 1. Factors, again, are things that are multiplied. So this thing is 1, this thing is 1, this over that is 1. And so I've removed that factor of 1 and I'm left with the 16/5. All right? So that process that you go through in arithmetic, we're going to use that when we factor our quadratics or our cubics or our quartic polynomials, etc. And it also underlies, it shows what's working here with our process of multiplying with fractions, right? Part of our goal today is to multiply rational expressions. And so how do we multiply fractions? Well, it's numerator times numerator, denominator times denominator. We're still going to use that process here. I know I'm doing a lot of explanation of 3rd and 4th and 5th grade math here, but whatever. We'll work that out as we need to. As we can see here, this is a 6 times 7, this is a 6 times 9, and so we get quick enough in high school and post 5th grade math that we can go ahead and say, oh, that's a factor of, it's a 1 over 1 is how that 6 over 6 simplifies. And so obviously we want to be able to do that. We want to be able to handle that process of simplifying these fractions. But again, what you don't do when you see this is you don't go ahead and say, oh, there's a 4 here and a 4 there, so that's going to be 2 over 5. Right? There are some classic mistakes that people make when they are doing arithmetic, especially when they misremember or misunderstand a shortcut. All right, and so that idea of canceling is problematic because we do silly things. We're like, oh, there's 1x there and there's 1x there, so now I have just 1 over 5, or worse, maybe I have 1 over 6, right? 1 over 1 plus 5. And folks, that is not how that works. That is not how simplifying works. We can only cancel, as your elementary school teacher would have said it, we can only cancel common factors in numerator and denominator if they can pull out as that factor over itself and that only can be a factor if it's been multiplied, right? If it's being multiplied. So same thing here. I don't cancel these x squareds because there's an x squared and an x squared. It's not how this works. If you have confusion on that, then just substitute x equals 3 and see what happens, and see if that works out. What if x equals -2? Does that change your expression? And you're going to find out that it actually matters what x is, and so x squared, it doesn't just disappear, right? We'd have to factor that to do that canceling. So here's what we're going to do. We are still thinking about considering our domain and our range and all that awesome stuff, as we did with identifying holes and identifying asymptotes and all those things. It's really relevant and it's really important because it keeps us thinking about what it is that we're doing. And so here we get to do some simplifying, some stating of the domains. I want to make sure that we do a very good job with this. And so we're going to recognize that when we factor this, we can factor out an x on top, and that gives us x squared minus 5x minus 24. In our denominator, I factor out an x, and I'm left with x squared plus x minus 72. This quadratic I can factor as factors of -24 that add up to -5 are going to be a -8 and a +3, and so I can factor that as such. Over here, this factors of -72 that add up to 1 are going to be a -8 and a +9. And so here we can see that we have a canceled factor here, an x over x, an x minus 8 and an x minus 8. And so I am left with x plus 3 over x plus 9. Now there's some interesting things here, right? At x equals -9, we're going to have an asymptote, and at x equals 0 and at x equals +8, we are going to have a hole, all right? But for all of these values of x that make our denominator equal 0, those are going to be excluded from the domain. And so there's a couple ways that we can say that. One, we can say x cannot equal -9, 0, and +8. But I want to make sure that we understand that for our domain, x will go from -infinity to -9, from -9 to 0, and from 0 to 8, and then again from 8 to +infinity. All right, so that is our whole domain. We are missing a value at -9, we are missing a value at 0, we are missing a value at +8. Both of these should be considered. This is the one I care about being written. This one can be written in addition to that. These kind of mean the same thing, so we want to make sure that we understand that. Real quick with letter B, the first thing I want to address is the fact that for this one we have 4 minus x squared. And that's kind of backwards for how we typically write that. If I factor out a -1, now I have x squared minus 4. All right, so if I'm going to factor out a -1, then that means that I would have a -1 times -4 plus x squared. And having the x squared second, right, not in the correct order, kind of messes with us a little bit. So we always want for our lead term to be positive. So folks don't want to write -1 x squared plus 4. Instead, they want to write 4 minus x squared. But standard form would suggest that the x squared needs to be first. So when we factor that -1 out, we then see that we have this -1 times x squared minus 4, and that x squared minus 4 can be factored further. So our numerator is going to be this factored pair again, because this is a difference of squares. In the denominator, we're going to have x times, let's see, x minus 5 and x plus 2 are going to give us x squared plus 2x minus 5x, and then minus 10. And so what we have here is these cancel out, and we are left with, and we can leave this in factored form. We can leave this as -1 times x minus 2 over x minus 5. But our domain here is that x cannot equal -2, because there's a hole, and it can't equal 5. So x is going to go from -infinity to -2, and again from -2 to +5, whoops, and then again from +5 to +infinity. Sorry for the handwriting there. And so this is our final answer there. Do I need to rewrite that as the opposite of x plus 2 over x minus 5? You don't have to. You can. You're welcome to. Can I write that as 2 minus x over x minus 5? Yes, you can, but you do not have to. Leaving it in factored form is fine for now. We are going to do some combined like terms and some distribution and stuff like that when we are adding and subtracting with fractions, but for now, we can just leave that in its factored form, and I'm cool with that. All right, so again, do the factoring, state the domain. I'm going to do letter C real quick, show you what that looks like, and then I'm going to have you do letter D. If you want to work on letter D and pause the video while I'm doing this next one, that's fine. But on this next one, again, these, I don't like the order of those, so I'm going to rewrite that as -1 times 24x minus 18, and then I'll do some factoring from there. So I'm going to rewrite that as -1 times, these have a common factor of, it looks like 6, so maybe I'll just make that a -6 times 4x minus 3. And then on this one, looks like I do have a common factor of 3, so let's do that, and that leaves me 4x squared, let me pull that out here, 4x squared plus 17x's minus, why did I say 4? It should be 3. 3 times 4, 3 times 17, and 3 times 15. And so here we have this in its factored form. Oh, we have a -6 over 3. And we know that -6 over 3 will simplify as -2, and we'll take care of that here in just a little bit. I'm going to leave that in there for now while I finish factoring this denominator. So when I factor this denominator, the thing that I want for us to do a good job with is recognizing our situation here. So we've got a 4x and an x. I could have a 2x and a 2x, but let's do some guess and check here. This is going to be -60. That add up to 17 is going to give me our positive 20 and -3. And so we'll have 5 and 3. Let's see, this gives us 20 and 3. That's what we need. I need a -3 and a positive 20. So there's our guess and check. Again, you can do this long ways. You can do it AC method. You can do it tic-tac-toe. You do need to know how to factor, though. That's not going to go away. This is one of those and one of those. This is 2 and 1. And so we end up with -2 over x plus 5. That is our final answer. Our domain is, again, x cannot equal 3/4. It cannot equal -5. And so we will have our domain goes from -infinity to -5, from -5 to positive 3/4, and from 3/4 to infinity. All right, so that is our domain. You're going to do letter D there. And then you're going to enjoy seeing that and checking with you on that. Okay, so that was, again, doing some work with simplifying our rational expressions. Now we're going to be doing, again, how does multiplication work? So when multiplying fractions, it's numerator times numerator, denominator times denominator. And so the way that we do that is a couple different ways. We can either multiply the whole thing together, and then simplify them separately, right? Like this is, let's go ahead and say that this is, I want 1/3, here's what I want. So this is 20 times 1, and this is 20 times 3, and so I can cancel out the 20s, right? We've got 20 over 20 times 1 over 3, which gives me 1 times 1 over 3, which gives me 1/3. All right? So there's all that work that we do there. The shorter cut that you would have learned in, again, your elementary days is to say there's 1 4 here, there's 3 4s there. There's 1 5 here, there's 1 5 there. So now I'm left with 1 times 1, and I've got 1 times 3, that gives me 1/3. Folks, I don't care how you simplify your fractions, I just care that you can simplify your fractions. And if you understand that arithmetic process, then that should not be a challenge for us. Here I have 2 2s, here I have 1 2s. I don't have any common 3s, no common 5s, so this gives me 2 times 3 makes 6, 5 times 1 makes 5, and again, that is as quick as it should be for simplifying fractions. Again, if we are very, very used to using our calculators to simplify, that's not going to be helpful here, where we are trying to write our rational expressions in their lowest terms. All right? So I'm going to do one of these, and I'm going to ask you to do one. Again, the goal here is, can we factor? Can we factor well? So here I have x minus 3 in that numerator. On this one, it looks like I've got 3x and x. I need to have a, this adds up to, this makes 9, -9. So I need a +3 and a minus 1. Is that right? That's a 9 and a 1. Okay, good. I've got that one factored. Let's go ahead and then take a look also at this other side. Here I've got a common factor of at least 2. That gives me, there's a 3x squared and a 14x and a negative 5. Here I've got a 4 times an x minus 3. Looks like I'm going to have to factor this one more. So I've got x minus 3, 3x minus 1, x plus 3. I've got a 2, 3x and x. Again, I need to have a plus 5 and a minus 1. Here's a 4 and an x minus 3. So again, doing that factoring, it's critical, right? Can you factor and can you do it efficiently? Hopefully it's not taking you 2 or 3 minutes for this, 2 or 3 minutes for that. You want your factoring to go well, and you want it to be efficient. If it's going too slowly for you, it's just going to make this feel like agony. All right, so again, an x minus 3, that's a 1 now. X minus 3, that's a 1. I've got 1, 2, I've got 2 2s. I've got a 3x minus 1, there's one of those. A 3x minus 1, there's one of those. I'm left with 1 times 1 times 1 times x plus 5. I've got a 1 times x plus 3 times 2 times 1, so I end up with a 2 and an x plus 3. And that cannot be simplified more. All right, stating the domain, we got to go back to our original expression here, and we say that x will not equal 1/3, negative 3, and positive 3. All right, so I will say my domain goes from negative infinity to negative 3, from negative 3 to 1/3, from 1/3 to 3, and then from 3 to infinity. All right, that's the whole domain there. I want to make sure that we get through all of those. You try letter B. All right, you do the factoring. This is something you can do. You can factor and then cancel those common factors. If you're struggling with writing the domain or you're struggling with simplifying the fractions, we both need to know that, right? I need to know that. I need to see that in your notes that you're struggling with it, and then I need to talk about it with you in class. All right, division. All right, division, again, like I said, today's supposed to be the easy day of what's coming up. Because when we're having to add and subtract, we need common denominators, it's going to get pretty messy. But when we are dividing, the shortcut that you learned, I think, was like KFC, keep, flip, change. And that's where you keep the first one, you flip the second one, and then you change this from divide to multiply. All right, and that works, right? However you remember it, it's fine with me. That's fantastic. Let's see what this looks like. This actually gives us 48 over 25, which can't be simplified. There's no common factors in numerator and denominator. That is the way that it is. It looks like, oh, I've got some things I can cancel, but no, that is not the case, because when we divide, we're doing 4 divided by 5, we're doing 5 divided by 12, and we're working that across. It doesn't really work out for us so well, and so we have to consider that division is the same as multiplying by a reciprocal. So here, these won't be simplified more. We are going to multiply by the reciprocal, and that's going to give us a new fraction that may or may not be able to simplify, all right? If we have this where we can do some of that fancy canceling like you learned in elementary school, great, but otherwise, we're just gonna multiply straight across. Now, you will notice that I actually did the multiplication here. I have 4 times 2, I've got 5 times 3. I'm not gonna be super concerned with us writing these in a standard form. Leaving it in factor form is going to be fine for today, and so I am very, very okay with that. So let's go ahead and do some actual examples here, some actual high school math. And while we think through doing this division, we want to make sure that we can do that factoring either along the way or in addition to that actual rewriting of the deal. So I'm going to rewrite the deal. I think that is the healthy approach. But as I'm going, I should be processing these things. When I'm rewriting it, I should recognize that, oh, that's a difference of cubes. I can factor that using difference of cubes. Oh, that's a difference of squares. I can factor that pretty quickly using a difference of squares. And when I move these into these new spots, I can see that I cannot factor those anymore, so I'm going to leave them the way that they are. But over here, I have to recognize that I've got a 2x minus 1 times a 4x squared plus 2x plus 1. Here I've got an x plus 4 and an x minus 4. And I'm multiplying that. I can put them all in the same thing if I want to, because when we multiply fractions, we combine them into one giant fraction. Or if you like to keep them separate, you can. That's fine with me. And we should notice that we've got some common factor in the numerator, 1 here and 1 there. I've got a common factor here and here. And so I am left with 4x squared plus 2x plus 1 over x minus 4. Our domain here, x cannot equal positive 1/2, positive 4, and it cannot equal negative 4. So our domain is negative infinity to negative 4, sorry for the handwriting, from -4 to 1/2. Whoops. And from 1/2 to 4, and from 4 to infinity. All right, you've seen an example of how to divide. All of this, the only thing that you want to worry about is, can you factor? If you can factor and you understand how to flip the second fraction and multiply and cancel common factors or find a common factor of one, numerator and denominator, then you want to be able to do those things. Keep your eye out for this one. I would rewrite this as -1 times x squared minus 1. All right, it's the opposite of x squared minus 1, and then factor that quadratic from there as the difference of squares. All right, so go ahead and do that factoring, and then we'll obviously touch base in class. Factoring is the key here. If you cannot factor, this will be rough. If you cannot factor, you need to see me. If you cannot factor and you don't want to see me, you need to talk to your tutor. If you don't want to talk to your tutor, then you should go and visit your Algebra 1 teacher here at GEHS, or come see me. Yeah, you just humble pie here. Let's go ahead and make sure that we can do the task of factoring that we've been practicing since October. All right, that is the end of the things for today. Hopefully you are able to multiply and divide rational expressions. Factor.